Hi, this is Derek Daily, and this is my C3 video. I'll start right away by showing you what my half adder circuit looks like. As you can see on screen, I have it already pulled up. So, what is a half adder? Well, it allows the addition of 2 bits. And, as you can see on screen, I have it all set up already. So, we have our 2 inputs over here, and then our sum and our carry. And I also labeled them as least significant and most significant bit to help understand the values. So I'll demonstrate by testing some inputs. So what is 1 on its own? It's just going to be 1, so that makes sense. And then let's add 2 bits together, which would be 2. So it's 0, 1, which is 2, so that's correct. Not much to do with this one, but it does get the job done. Now let's check out the full adder. So here is the full adder, and what might a full adder be? Well, it allows the addition of 3 bits. And fortunately, longhand addition involves 3 bits in any column. So this exacts that exact thing. As you could see, we could try adding in 1, which is 1, which is right. 1 and 1, which is 0, 1, which is 2, which is also right. And if we add all 3 inputs together, we get 1 and 1, which is 3. Very handy. Now, you might be curious as to why there aren't so many gates on the screen. And that's because logisim allows us to use our subcircuits to be utilized in a hierarchical design. Oh man, I'm going to butcher that. Hopefully you understand what I just tried to say, but essentially, the half adder circuit I showed you previously, I'm able to drag it on and reuse the circuitry from earlier. So it allows for a bit of abstraction and a bit of convenience. So going back to the full adder, it uses the sub-circuit system to create this hierarchy, which is pretty handy. And in this case, it allows us to create a full adder of 3 bits, which is pretty handy. So now that we've seen it and tested it and explained how logisim allows for subcircuit structure and hierarchical design, let's check out our 4-bit adder. Alright, so this one I used 4 full adders to demonstrate longhand addition, and essentially it's relatively the same system as before with the full adder. You have your inputs, it goes into each corresponding full adders, with the least significant on the right and most significant on the left. And as you can see, at the start you have your C input or carryover input, which is usually 0, and then you have all of your inputs. And as you can see, it's a little complicated, but it does allow you to do longhand addition between 2 4-bit values. So let's check it out with our tester. As you can see, I have the same exact input as the C3 assignment. 4 plus 2 does equal 6. You could have your carry, which adds 1, which is 7, which is accurate. So as you can see, there is a lot of convenience with the hierarchical design that logisim allows you to do. If we were unfortunate enough to not have it, well, if we take a step back, we look at the 4 adder. For each of these full adders would be this circuit plus the half adders in there as well. So if we're looking at this, there would be a total of 4 of those circuits and 8 half adders, which is quite a bit. So thankfully, logisim allows for hierarchical design. And yeah, that is my C3 video. Thank you very much. Have a nice day.